Hello, everyone, and thank you for joining us today for our webinar on why you should invest in mixed reality for your construction projects. Before we get started, just a couple of housekeeping notes. This webinar is being recorded and will be sent out via email once we wrap up. And also for any questions that may come up during our webinar and throughout the presentation, please submit them in the questions tab, and we will answer as many of them as possible during our Q&A portion at the end. And now I'll hand it off to Jordan Lawver, our Trimble Mixed Reality Portfolio Manager.
Thank you, Hannah, and thank you everyone for joining in today. As Hannah said, my name is Jordan Lawver. I'm the Portfolio Manager here for Mixed Reality at Trimble. And joining me today is Bryan Williams, our Segment Manager. How's it going, Bryan?
Hey, doing well, Jordan. Thank you. Good to be here.
Yeah, thanks for coming. So Bryan's going to kick us off today. Here's a brief agenda on our session. He's going to kick us off with an overview of Trimble. Bryan's been around for a bit longer than me, so he's a little better suited to give you guys an intro to Trimble as a company. Then we're just going to kind of bounce back and forth on a few topics. Our main goals for this webinar are to really just give a bit of a deep dive on mixed reality and in particular in construction. So an introduction to the technology and kind of how it has gotten to where it is today. As well as some of the real life use cases that are being explored and used through mixed reality today. This isn't going to be a presentation talking about the future prospect of what we can do with mixed reality 5 years or 10 years from now. We really want to focus on where it's driving value today, and then of course show you guys some of our solutions that are both new and old for the market. And kind of what new things we're putting out there. So with that, I will hand it off to Bryan to give you guys a bit of an overview on Trimble.
Yes, thank you, Jordan. Appreciate that. I heard you mention my experience there, so we'll talk about that later. So everybody, I know a lot of people on the call probably know of Trimble or have heard of Trimble. They may not be aware of how diverse Trimble is. We are a multinational company. We have coverage across the globe. We're very focused on a very diverse number of industries. We divide that into some core franchises. One that Jordan and I are focused on is particularly the buildings industry. But you may have seen us in many other areas. Certainly, if you're driving down the road, you'll see Trimble product on pretty much every civil project that's going on around the globe. Whether it's a bridge or whether it's a road, through our civil construction group. You might see surveyors on the road. You might see people in your local community and local governments using our solutions through our geospatial group. If you see a truck running down the road delivering product from place to place, there's a good chance they're using some product from our transportation and logistics group. And then if you get further outside the city, you'll see tractors. If you may not notice them, a lot of them are actually driving themselves, and that comes through our agricultural group. So what Jordan and I are going to focus on, and the experience that we've had primarily with this technology, is through the buildings group. And the Trimble buildings group is really focused around trying to provide productivity solutions across the whole range of concept through to actually running the building. And you may not know that about us, but we provide those solutions. Whether you're using a product like SketchUp for your conceptual design in the early part as an architect, or actually as an owner, you might be reviewing that. But then we get into the realm of where we're actually providing high-level detail to have a fully constructible model that is used during the construction process. So putting a building together takes a lot more than just a plan or a vision. It takes a lot of detail, and so that constructability is very important, and Trimble is very focused on that. You may have heard that term used in different ways, such as BIM, which is more of a process than rather the actual detail of the constructible part. And then part of that process includes a lot of content. So when you get to putting the building together, there are lots of bits and pieces down to the actual nut and bolt that have to be part of the construction process, and that information has to come from somewhere. So there's a lot of content for providers providing all the parts of a building, and Trimble enables that connection with the content into the design model. And then more importantly is also the data that goes along with that. So as you go through the process, being able to get connected with information, and this is not just being connected, say, by the internet, it incorporates a lot more information related to that, not just being connected, but also having the right data that you're being connected to is a very important part of the whole building's life cycle. So it's important there. What Jordan and I are going to discuss today is several technologies that will help you visualize information and also be connected to that content-enabled information that makes it more viable for you to have success in the construction process.
Great. Thank you, Bryan. So I think that's a great segue off of this kind of high-level constructible message and some of these key characteristics around content enablement and connectedness and constructability. And we really feel that mixed reality is kind of the missing piece there. So before I dive too far into that concept, for those of you who may be newer to the technology, I'd just like to give a bit of an overview into the difference between virtual reality, augmented reality, and mixed reality. So virtual reality is probably the one that most are most familiar with. This is what you see in gaming or in architecture studios or even at your local mall. It's a fully immersive technology where one puts on a headset and it completely removes you from your physical environment and essentially transports you into a different world that is made up of digital data. So, in construction, this is mostly being used on the design review and design visualization side, mostly in architecture, because it gives a much better kind of immersive 3D understanding and fly-through of your design than visualizing on a laptop or on a 2D paper plan can. So the idea of augmented reality is the ability to kind of enhance your environment. This tends to be done in kind of what we would call like a 2.5 dimensional fashion today. And when I say that, I mean that you're consuming usually 3-dimensional data, but usually through a platform that is still 2-dimensional, whether this is through like a phone screen or through something like a heads-up display, like a Google Glass type of device. So something in the consumer world that is augmented reality is Pokemon Go overlaying a Pikachu on your street, or even like a Snapchat filter overlaying onto your face. In construction, and we'll show this a little bit later when we talk about sight vision, what we can do is essentially pass through the camera view and then overlay 3D content on that camera view so that you can kind of use your phone or tablet screen as kind of a portal view into this kind of subworld of information being overlaid on your environment. So when we talk about mixed reality, we talk about kind of a more advanced model of augmented reality. So the devices that are doing mixed reality today, HoloLens being an example, are much more sophisticated in their ability to understand the environment around them. At all times, they're tracking their own movement through the environment. They're mapping that environment so that when they overlay this 3D content or holograms, and in a lot of cases in a binocular fashion, so actually 3D to your eyes, that data is interacting with the world as if it were physical data. So for example, the device would know that I'm sitting at a table right now and that there's a physical table in front of me. And if I had a digital water bottle and I placed that out in front of me, it would actually intersect with the physical model. I wouldn't be able to push it through the physical tabletop. And so the idea around mixed reality is to really kind of merge the two worlds of digital and physical so that our usage and our understanding of our digital data feels as lifelike as it would if it were real data out in our environment. So these types of technologies have been around for quite a long time, especially when you go back into virtual reality. And for decades, really, there have been all kinds of ideas of how it could be used, many in the consumer space, as you would expect. And for many reasons, it has caught on in some places, but really not in a lot of mainstream places. At Trimble, we've kind of looked at this a little bit different, and not saying we're the only ones who have thought this way, but from very early days, we've seen this as a technology that can solve some of the biggest issues that we're faced with in construction. So I have the top 3 outlined on the next few slides. The first is really pretty simple. It's a better utilization of all of the investment that goes into 3D content. So whether it's capturing that 3D content, whether it's with a laser scanner or a total station, or creating 3D content like in SketchUp or Revit, or even 2D information, estimating data and scheduling data. We're just surrounded by this massive swath of information. And we truly believe that the industry isn't properly getting the information out of their data that they could be by, properly kind of connecting it to the real world where it is relevant. So this kind of goes into the idea of the data disconnect. So as many of you know, those who are more advanced with their BIM workflows are creating beautiful 3-dimensional digital twins of their projects before they actually go and build them. And then, of course, when we actually go build, we're building in a real world that is 3-dimensional and physical. But in many cases, still in the middle, we're falling into kind of this trough of mostly 2-dimensional information. On any buildings construction site that you go out on, there's still 2D printed paper plans. There's still iPads, which is inherently a 2-dimensional device. You're flying people all around the world to different sites. You're building, multi-million-dollar BIM caves. There's all this kind of middleman information that's trying to bridge this gap of a disconnect between 3D content and the 3D world in which it's being built. And last but not least, probably most importantly, is this idea of bridging the mental model. When you go out on a building's construction site, I think there's something on average like 72 different stakeholders and different trades on a construction project from start to finish. And really what they're doing is they're building a puzzle together. And it's all kind of this intertwined, amazingly complex physical and scheduling and estimating chaotic mess many times. And so the idea of mixed reality is kind of this idea of if we have a common data model, that constructible model that's connected, it's one thing to connect it from human to human. And that's what you see in platforms like Trimble Connect or Autodesk BIM 360 to better collaborate between stakeholders on a project. But the last connection piece is really getting that data in situ, in context of the site, so that everyone is working on the exact same mental model of what it is they're building from day one. And so what this avoids is kind of cost and schedule rework over time and kind of this snowball effect when someone thinks, oh, I thought we were doing this, and it's not quite what was actually planned, and their mistake tends to snowball into other people's work.
So Jordan, I have a question for you.
Sure.
So I think a lot of people on the call might have this same thought. So we're talking about visualizing things in 3D, but you mentioned that there's still a lot of 2D plans used on the job site.
Sure.
So with this technology, can I merge and view these two types of data in that one device?
Yeah, so it's an evolution, right? Like it's a bit of both. Today, it's very much BIM-centric workflows of kind of taking this 3D content from the office and to the field and overlaying it. But what we've seen recently and what we've been working on in our applications is kind of that, what you're saying is kind of that hybrid mode, right? It's not necessarily pulling up, a 2D panel directly in an application in kind of this 3D environment, but kind of pulling some of the data out of that 2D drawing, measurements, for example, and being able to overlay that out on the site, but in a kind of more contextual 3D environment.
Beautiful.
Yep, very cool. So I wanted to touch a little bit on the history of kind of where we've been going with this technology. And I think this is important because it shows kind of the commitment to solving these problems and really how long we've been thinking about this. So what you see here is actually a patent that Trimble got in 1997. It's one of the first patents ever. I think it's the first that was hard hat integrated for an augmented reality headset. And there's a really cool video if you guys go on YouTube and just search like Trimble 1997 augmented reality. It was the exact same thing that we're talking about. These guys, and a couple of these guys are actually still at Trimble working on this project. They integrated this system and they walked out on a site and they visualized their design actually in the context of the site. And, you know, for many, many reasons, it wasn't ready. As you can see, it's pretty dorky and it's huge, and the processing power, I'm sure, wasn't great in 1997 to render a whole lot of things. But the key here is that the idea was there, and there's always been this desire to kind of fix some of these problems. So if you jump 18 years ahead, you hop to Microsoft HoloLens. And Microsoft introduced this new mixed reality device in early 15. And by the time they had announced it, we had already been working with them for nearly 2 years on kind of developing software and ideas around this device. Because, you know, many in the industry recognize this as the first realistic mixed reality device to hit the market that could actually solve some of these problems. As many of you know, over time, we kind of learned that, you know, the first HoloLens device was great for prototyping and proof of concepts. And it's been a continued evolution of, you know, seeing what can't HoloLens 1 do. And that has driven a lot of the change and the evolution of this technology over the last few years. So back when we started working with Microsoft in 15, most of our work was around architecture. We were curious what we could do in mixed reality as well as virtual reality around kind of enhancing the design review, design visualization, and collaboration between architects, owners, and GCs. So in 16, we actually launched a SketchUp app on HoloLens. It's been pretty widely popular. And it really kind of changed kind of some of the thinking in the architecture community about how we could interact with this data. And Bryan's actually got a really cool anecdote for you guys later on how one of our customers is using SketchUp Viewer. So jumping ahead a couple years, from there we turned a lot of our focus to on-site construction. We started to realize this vision of constructability and this kind of future vision of being able to kind of build off of what you are being given in a mixed reality environment. So we launched our app, Trimble Connect for HoloLens, which is kind of the counterpart to the SketchUp Viewer application for taking this data actually out on a site. We also created some cool clips that you could take a HoloLens 1 and incorporate it into a hard hat so that you would actually be safe out on site. And this is where the floodgates really kind of opened on ideas of how mixed reality could really transform the way people are working out on site. So like I said, this has been kind of a continual evolution for us and Microsoft as well. And so earlier this year, we announced on stage with Microsoft the new Trimble XR10 with HoloLens 2. So this is kind of our second generation hard hat integrated mixed reality device. It's a much tighter integration. It's not just taking a HoloLens 2 and kind of adapting it into a hard hat. It's a completely different device to the HoloLens 2 that's actually purpose-built for construction sites. And then in parallel, also kind of our new version of our application, Trimble Connect for HoloLens. And I'll dive into this a little bit more here in a few slides. And then in addition, I haven't touched on this yet, but it's really just as important, is Trimble Sight Vision. So this is another realization of a project that we've been working on for over 20 years. And this is kind of the idea of augmented reality for the worker outside and in the field needing high precision place data. So this is an augmented reality device that incorporates with a few centimeter precision GNSS and allows users like civil engineers, earth movers, utility workers to go out and actually visualize their data. It's very high precision, either where it's going to be built in the case of like a design review, or visualizing buried utilities and those types of use case. So very complementary to the XR10 solution, which is kind of the more buildings construction on site in the building workflow, and now being able to do those very similar types of workflows out in the field. So before I dive in too far there, I don't want to bore you too much with the technology. I really want to dive into what these are actually doing in construction today. Again, this isn't kind of future-looking vision. This is the main use cases that we've realized up to this point for this technology in on-site construction, and then a few anecdotes of how our customers are using it and some of the ROI that they're seeing. So I'll hand it to Bryan for that.
Thanks, Jordan. I liked looking back in time when holding the computer with lots of wires hanging off it with a big GNSS receiver, where everything's now on your head or in a phone.
Yeah.
Quite amazing.
Pretty impressive.
Yeah. So I'm not sure you were born before 1990. Too funny. So let me connect a little bit this mixed reality capability with Sight Vision and the XR10, and how it fits in with how different customers are using the different technologies that we work on the field technology group. So you can see here on this slide that we have some traditional technologies such as robotic total stations and GNSS receivers. We have thousands upon thousands of contractors using this technology in relation with our field software called Trimble FieldLink that allows them to take a constructible model into the field on a tablet, connect to a positioning device that allows them to execute the design intent and make sure that whatever's happening on the job site is being executed as designed. And so it's really this taking the digital information instead of on a plan and executing on a job site and supplying that true workflow. And so if you want to have a traditional workflow where you just have a digital plan, but you want to execute it more securely, more accurately, more productive, then you can use these tools. If you want to execute on the BIM process where you have all the detail of a 3D model with the BIM information, you can also have that power in a tablet in the field, but with a positioning device. As you work along the job site, whether it be reconstructing on an existing site or wanting to track anything to do with 3 dimensions on a job site, 3D scanning technology is the way to go. So we have 3D scanners today that allow you to not only collect a large amount of data, but also to visualize that now in the field and compare that to your model. So we have the release of the Trimble XR10 that allows you to do that. So that's probably another webinar that would be invested into to explain that to people. And then on any job site, you need to make sure that it's secure. You make sure that the right people are working on the job site, tracking who is coming on and off the site. So we have a solution for that called Trimble CrewSight, and that complements the whole process that we try to focus on in providing all the type of tools for any construction job site. So I think that our colleague Matt would probably delve into that a little bit more on another time as well. But if you look at specifically the mixed reality products, as Jordan mentioned before, if you look at the early stages, probably very well suited to architectural applications where you could view, visualize, and conceive the concept around putting a building together and why the owner is looking to occupy that space. We want to take that technology from there and put it in the hands of everybody involved in the construction of a building. So what we've done with Trimble Connect for HoloLens is provided the functionality that gets the coordinator of any project, so a general contractor, involved in the early stages, taking that concept, making it more constructible, trying to figure out the sequence of construction, getting people ready to work on the construction site. So things like training, especially if you're working on sites that require minimum access, and you need to make sure that the right people are there at the right time. And then also making sure that they're managing all the tasks that are being carried out on the job site as well. And then in the end, they're also responsible for any of the verification of what's been installed and what's been constructed at any point during the project as well. Then we start to look at all the pieces that come together to put this building together. So there are things that are pre-constructed off-site for any job, whether that's a small piece or even a large piece. So if you look at a smaller project, it might be a piece of ductwork, it might be a pipe, it could be a pre-constructed metal cage, it could be even something as large as a full beam that is the part of a ceiling of a new, a good example would be, say, a sports arena, where they have very large pieces that have to be brought in by super large cranes that are very complex. So a lot of those pieces in prefabrication can be small or large. Then we have a lot of subcontractors working on any site. So you have MEP contractors, you have steel contractors, you have concrete contractors, and quite a long list of other contractors to do installation of all the bits and pieces that come together in a building. And all of these people need to have that continuation of that information that Jordan had talked about, and making sure that they're all aligned on the same task and getting sequenced together to finish the project as not only as designed, but also to making sure that it's done as close as possible to the timeframes that is set out, so that the owner can occupy the building. So this technology allows these people to all be sequenced together and to make sure that they're all viewing the same type of data. As Jordan mentioned before, you still go to a lot of job sites, and this is not to berate the success of people still using paper information. But if you look at any job site, many people are walking around with different pieces of paper, making notes on those pieces of paper and not sharing that information. So having a platform that allows people to keep sharing that information and updating that information is going to be valuable to make sure that all these people are sequenced together. And then we come to the handover of a building, and a big part of any building and the cost of any building is the actual maintenance and running of the building. It's pretty much, I think, around about 80% of the cost of a building over its life cycle is actually running and maintaining the building. So this technology then can carry over into that maintenance part of the building. So you can see that mixed reality technology can span across the whole life cycle here, from concept all the way to actually maintaining and running the building.
Yeah, and I think the cool thing here, Bryan, to point out is that everything that we have on the slide are things that we have documented anecdotes from customers and real ROI. These aren't us looking kind of future of the things we'd like to do with mixed reality, but really focused in on what our customers are using these tools for today.
Yeah, exactly. And that's a big part of what we do. We have many people in Trimble that come from the industry, have a lot of experience, but we spend a lot of time talking to customers. And I know that you've spent a lot of time trying to figure out with this transition from the early technology through to what we have with the XR10 and HoloLens 2, the capability that we're going to offer these customers to get through this sequence and have the different type of functionalities that they are to carry out these tasks. So anything from design review through to visualization, through clash and coordination, whether it's guided assembly in a prefabrication environment or carrying out some sort of task management and sharing that with people. And then also the validation and making sure the installation is there. So we have some of this information outlined on this slide, and as we had mentioned at the start of the presentation, that this information will be available to you later, so you can read through it in a little bit more detail as well.
All right, so time for us to put some proof in the pudding, right, Bryan?
Definitely.
Let's talk about some examples from some customers that we've had over the years.
Yeah, so Jordan, you mentioned early on that the HoloLens 1 had a application called SketchUp Viewer and was very popular. I think it's still quite popular for people viewing and visualizing information. And so a good example there is if you're an architect and an owner, you have to coordinate together on the vision that you're trying to set out together to execute putting a building together. So here's a good example of that. A hospital is a very complex building, probably more complex than people realize when they walk into it. There are lots of bits and pieces that have to function really well because you're talking about all of our lives. If you walk into a hospital, whether it's just for a checkup or whether it's an emergency situation, a hospital has to function in a manner that is optimal for everybody working in that environment or entering into that environment. So here's a situation where an architect was able to put together a design, a very detailed design in SketchUp, and present that in the SketchUp viewer in HoloLens. So what they did was they built the model. They went to a large space where they could present this model in a one-to-one scale so that they could have people walk in that environment. So what they did was they rented out at a warehouse that was simulating to the size of the actual hospital. They outfitted people with the HoloLens, with the SketchUp viewer. And so people then could visualize the space one-to-one as if they were in that environment prior to it being constructed. So what they had was they had people that are working in an environment. A good example is a nurse, and had them walk in the space and evaluate the space as if they were working in it. So a good example was just a simple thing as a nurse walking from the nurse's station, walking over to the ice machine and bringing that back again and providing that to the patient. Now, it seems like a onerous task to be doing something like that, but if you have to think about having to do that potentially hundreds of times or thousands of times in a day or a week, adds up to a lot of time. So what they realized by having somebody who's actually going to work in that environment, carry out that task in this simulated environment, fully immersed with the mixed reality technology, without able to determine that it was positioned in the wrong location. So it really helps them to discover with this technology what's going to be optimal before they actually start executing and building the environment. Because making a change like that later on, it's either going to cost a lot of effort and time for the people working in that environment, but also if they have to change that, that's a big change cost, right, to do that later on.
Yep.
So
yeah, and in that project, I think the key there is, how efficient you want your nurses and doctors to be, especially in an environment like an emergency room where this was done. So, something very simple like that, that's not something that an architect by default would know, is that, hey, a nurse makes X number of trips to the ice maker every day. Exactly. And, if that's 20 trips and the ice maker is on the far side of the floor, every single nurse that's adding, X numbers of miles to their walking, and that's time that they're not spent with their patients. So they started to do a lot of kind of lean planning integration with mixed reality, this customer, and really found a use case for the SketchUp viewer that we hadn't even really thought of when we had built it, but very applicable and really something that just couldn't be done with any other technology.
Yeah, I think we find that it's a common thread that, of course, we speak to a lot of customers, but we can't think of every potential use of this technology, but we try to enable it so there can be a broad application, right? So,
yep.
Perfect.
So moving back out on site, Bryan, tell me a little bit about this project.
Well, so this project, if you look at the screenshot here, is probably a very typical office environment, sort of a typical sized office space for a larger company, and some of the people on the call would recognize it. It's based in Colorado, so we have a lot of contractors working on this job site to execute on it. Even though you see that the building is quite basic in design, I think just a square with 4 different floors, sort of an open environment. But still, to make that operate, and I think we feel in this room today when it's not operating well, we're a bit chilly. But there are a lot of bits and pieces that go to this building, and if you look at that, especially the mechanical parts of the building. So what happens when you start constructing? So you have all these great plans, all these great designs, and then you start constructing. What happens during the construction process? The different contractors then start to look at things as they construct it, and they start to validate or invalidate some of the engineering that's put into the building. So in lots of cases, what happens is early on, this building has a large steel construction part of it, and during this process, what they determined was the steel erectors determined that they needed a little bit more bracing around the building. So after they put the pieces together, they could see what was happening in the environment. They spoke to the engineers. They needed to add a little bit more bracing. So how does that affect anybody else? So what happens? The HVAC contractor comes in this case, a company called MTech, and what they have to do is to be efficient on this type of project, they do a lot of off-site prefabrication so that when the installers come on site, they're as efficient as possible, which makes it very productive to do the installation and also get it up and running and testing in the environment of the building. MTech walked onto this environment. They were supplied with the HoloLens technology. They put their design into the building, and because they were walking within the actual construction space with the 3D model one-to-one, they started to find some problems. So something that you may not see on a plan or in a model is a change that's happening during construction. Because in an ideal environment when you're designing, you're not seeing what's happening on the construction site, so you don't see the changes that are taking place. And if you're walking around these paper plans, making notes, and that doesn't get transposed back to the other contractors working on this site, then they don't know about the change. By having this immersive technology, such as the HoloLens, they were able to see that this new bracing that the steel contractor put up was going to create a problem for the HVAC system. The great part about that, they spotted the problem before the pieces arrived on site. They were able then to call to the prefabrication site to say they need these changes done, and thus change the routing, change the sizes and length of the pieces, and thus being able to avoid a costly rework actually on the job site itself prior to arriving there. So of course, what does that cost generally?
Yeah, it's a lot.
A lot of money.
Yeah.
So we see in a lot of job sites, and this has been validated by a lot of people, somewhere between 8 to 14%, in some cases higher, that you have, change orders done on the job site. So it's very cost prohibitive for the building if you start to add those numbers together. So what we try to do is try to avoid that, and you can see just this one incident is a large amount of money. So if the subcontractor, in this case the mechanical contractor, has to endure that cost of change, then it's going to eat into his margins on this project. So you can see how the technology here is not only helping on the productivity of the installation here, but also it's a monetary thing as well, and thus saving them their margin that they're working on in this building.
Yeah, and in this case, Bryan, they made that change without even picking up the phone. It's the beauty of kind of the integrated workflow through Trimble Connect is, they found the issue in HoloLens, but that's only part of the puzzle, right? Yeah. They were able to log it directly within the application. They kind of synced that over the cloud back to the office. The workers back in the office made the changes in the model, and then they synced it over the cloud to their prefab guys. And really, once the problem was found, it's really easy to solve, right? It's just a matter of finding those problems and being able to find them earlier in the process before they start snowballing into other people. We think about what may have happened on that job, and it's probably nothing new for anyone on this call, is, that HVAC assembly would have shown up and it wouldn't have fit.
Yep.
And so you would have either had a mechanical team that had to kind of hack it together, which
Yep.
could have implications on the other people coming after them. They're just passing the issue on. Or you've just got guys sitting around and waiting until the new parts come,
Yep.
and then adding all kinds of schedule and cost delays. So it's no surprise to anyone on this call, the cost of these change orders and how much that impacts the capital on any given project. And it's one of the key value propositions of mixed reality today, that it can help workers out on site avoid.
Yeah, I think the sequencing also gets affected here. So if one contractor gets delayed, affects another contractor, suddenly the whole piece starts adding up, and then you're adding to the timeline on the execution of the finalization handover to the customer. So,
yeah. And that's a great segue into our third anecdote.
A perfect segue in if you talk about doing prefabrication, and this is a good example. And we're going from Colorado all the way across the other side of the world, right,
Yep.
to
Up in Sweden.
Sweden.
Yep.
With a customer called Consolus. And so this company is doing a lot of prefabrication on large pieces for big projects, right? And so they're putting pieces together here. You can see here large pieces of rebar. They have other pieces of steel here as well in this workshop. And so what typically happens on these job sites? So you can see, I think in the picture, if you look closely, you can see pieces of paper on this job site here where they're reading off the paper, constructing. But you know what? They have a lot of very experienced guys. So these guys know what they're doing. So they have a lot of experience, and things can go well in most cases. But what's the problem is we're in a transition right across the construction industry where you have a lot of the older experienced guys now working together with the new generation coming through in the construction industry. So they're trying to hand over this experience. The problem with that is you're under time pressure. So a lot of that experience is hard to pass over in a timely manner to make sure that you're doing things productively. So what happens is you train somebody, you step them through the process, and you let them go and they start doing it. Problem is they start stepping through a process, especially if you look at this example of putting a steel cage together. If you go through the process and you get 10 steps into it and you realize you've made a mistake, undoing that is, wow, I don't know. You look at that, all this rebar tied together. If it's done incorrectly, it's a lot of untying and redoing the process there. Very costly to do it, very frustrating for everybody as well. So how can we help that out? Well, we have a technology, the HoloLens technology, with an application like Trimble Connect for HoloLens, can help them sequence through this process, can help them visualize it. What are the younger generations good at doing? They're very good at using technology, visualizing things in 3 dimensions. And so by placing this in this technology in the hands of these younger people, they can visualize through the sequence. And then as they're going through the process, they can identify things. So if you can have this 3D overlay of this 3D constructed piece of a building, you can start to see where I might start to run into some problems. So you're starting to see things ahead of time because I can actually visualize what I'm doing rather than trying to interpret a 2D piece of paper. And by the way, the older guys are very good at that because of their experience, but these younger people are not so great at doing that. So this helps that transition. And by using it in this pre-construction environment, they reduce the time frame of putting these things together. They reduce the potential to make errors that are going to not only cost them a lot of time and effort, but also material cost as well. Because if you have to undo everything, you have to then have new pieces to go in. Because if you look at these rebar, you can't just throw them back into place. You have to retie them together. So you can see in this pre-construction environment that it seems like a place where you may not use this type of technology. But in fact, the feedback we got from this customer was hugely beneficial.
Yeah. We actually ran a test with this customer, and we brought in 3 people who had never built a rebar cage before, and we gave them the HoloLens as well as the software app, of course. And we had them build a rebar cage, and right beside them we had three experienced guys from the line building the same rebar cage off of paper drawings. And believe it or not, our rookies built it 30% faster than the experienced team, and it was their first time building anything. And it's interesting because there's really two main things that the mixed reality tech gives in this prefabrication environment. One being that sequence, right?
Yeah.
You need to do step 1 before you do step 2. And if you accidentally do step 5 before step 3, you're going to be doing some rebuilding. And so you really don't do that anymore when you have it right there floating in front of you. And then it's also that spatial positioning, especially in a controlled environment like this. We can pull that precision sub-centimeter. And so not only is it showing you step by step, but it's showing you exactly where to put it. So rather than, using a tape measure, rebar to rebar based off of a 2D plan, you literally just put it where it tells you to put it. And so, in my mind, whoever figures out how to do this for IKEA is going to make millions of dollars.
Totally.
It's a killer app for building your dining room table. But it's pretty fascinating.
Yeah, I'd like to add here that if you see the trend in construction today, there's more and more emphasis on pre-constructed pieces, not only just rebar pieces, but large pods of pieces. So you see some hotels that are all pre-constructed pods today. You see that a lot in hospitals because you have rooms with all these connections and wires. So I think you're going to see the use of this technology in the prefabricated environment accelerate, in fact. So which I think works well to talk about what's new with the technology, right?
Yeah, sure thing. So thank you, Bryan, for walking us through some use cases and anecdotes. So I'm going to do a bit of a deep dive, here in a few minutes on kind of our new and improved technology. Of course, much of what you saw there is kind of what we've learned over the course of especially HoloLens 1, but really that 20 plus years of innovating through mixed reality. So it leads us to kind of 3 new pieces of technology to introduce you guys to. So the first is the software that's driving kind of everything from the background, which is Trimble Connect. And this really is our on-site application. Now, all those use cases that we just showed you are enabled through this software. I saw a question come through in the box about file support. It's the beauty of Trimble Connect. It's meant to be kind of this great unifier and collaborative tool among different stakeholders. So it doesn't matter if you're using Trimble tools like Tekla or SketchUp, or you're in the Autodesk world and you're using Revit or Rhino or whatever other types of industry standard formats. You can bring all of them together and kind of coordinate all these models together and then view it either on your phone, on a tablet, on the desktop, or in a browser, and then, of course, out in AR, MR, and VR through our Trimble Connect suite. And really, there's one goal here, and it's what Bryan and I have hit on pretty much every slide leading up to this point, this idea of identifying issues way earlier in the process just to reduce as much of that kind of downstream coordination chaos that tends to pop up on these sites. So some really cool new stuff in 3.0, which is our new version that just launched about a week ago. It's now in the App Store. We can create RFIs directly on the model and visualize them out on site. We now have large file support, so that was one of the barriers to entry historically on this technology. We can now take in pretty much any model in the application, and we're doing some really cool kind of video game-esque parsing and kind of real-time LOD, dynamic LOD, to make sure that you don't have to have any pre-processing on your data before you bring it into the mixed reality environment. All that work that went into Consolus, that pilot project around prefabrication, is now in production in the application. So you can go in there, you can load up a model, you can step by step through model sequence steps for that either prefabrication in a manufacturing environment or out on a large scale construction site for scheduling purposes.
So, Jordan, I have a quick question. So you mentioned this is the new version 3.0.
Yep.
If there might be some customers on the call here that have the original HoloLens 1,
yep.
Is that applicable for them?
Yeah, so we do still have Trimble Connect version 2.1, which is our current version for HoloLens 1. Fortunately and unfortunately, the new HoloLens is so drastically different and better, really, than the old one in the way that it works, that our new version 3.0, is not backwards compatible. It does not work on the first HoloLens. And the hope is that once you guys see the new HoloLens, you'll understand what we mean. But a lot of the new tool sets and functionality just really aren't possible on the old hardware for a number of reasons. So great segue into talking about the hardware. I mentioned earlier before the Trimble XR10. So we have a partnership with Microsoft. We're the only company in the world as part of this partnership. And we source components of the HoloLens 2 from Microsoft. So we don't just take a standard off-the-shelf HoloLens 2 and kind of hack it into a hard hat some way, kind of aftermarket. We're actually sourcing components from Microsoft. They're all HoloLens 2 based. And we integrate it into kind of this ring that snaps down on an industry standard hard hat. It's an MSA V-Guard hard hat. It's one that many of you are very familiar with. And, this is a goal of having a purpose-built mixed reality device for our workers out in environments that are dirty and rugged and require PPE and are loud. And so everything you see here on the screen are things that we've built towards that environment. And it's not just putting it in a hard hat. It was the certifications, both for the glass, for electrical, for the hard hat impact, of course, and for intrinsic safety. It's certified all around the world with all the different governing bodies to use out on site. We've done some really cool stuff around audio. For anyone that has used the HoloLens 1 out on a construction site, if it's trying to talk to you, you can't really hear it, especially if you're wearing earplugs or over-the-ear muffs. So we've added a bone conduction system into the XR10 package that allows you to do two-way audio. So whether this is for collaboration activities or for talking to Cortana, or getting those step-by-step assembly instructions through a sequencing tool without having anything in your ears. So you can still use earplugs, you can still use earmuffs, and you can talk to the device and have the device talk back to you or talk to someone on the other line, up to two-way audio up to 90 decibel ambient environment, and one-way audio out up to 115 decibel ambient environment. So very, very cool. I've actually got another slide on it, I realized. We've improved the drop resistance quite a bit. We've also added standard accessory mounts back into the device. So for those of you familiar, that same spot where your earmuffs click in on a hard hat, that's where the XR10 clicks in. But we wanted to make sure that you could still use all those same tools out on site. So we recreated it, and you can kind of see it in the photo there just above the Trimble logo. So that even when you're wearing the XR10, you can still wear a face shield or a chin strap or over-the-ear earmuffs and whatever's required out in your environment.
And Jordan, so just through experience, so the the XR10 allows you also to wear like glasses underneath the visor there, right?
Yep,
as well?
Exactly. So it's not like a VR rig. It's completely open. So whether that's your day-to-day, glasses that you need to be able to see well, or it's sunglasses, or it's your safety glasses out on site, you can still wear them behind the HoloLens. And as you can see on the front, we have a 190-degree, it actually says 180, it's a 190-degree flip-up visor on the XR10, so that when you don't need it, you can flip it up and get it out of the way, whether that's an emergency or just, talking to someone or just doing other work that doesn't require mixed reality. So this is just kind of a high-level view of some of the kind of added benefits of the XR10 over kind of the standard off-the-shelf HoloLens 2 device. If you want to learn more, you can download the data sheet at that hyperlink at the bottom. And again, that'll be shared out after this webinar. So here's a little more information on that audio system. You can see it in the photo kind of on the back of our model's head there. It is a system that allows you to use two-way audio up to very, very loud ambient environments, which is something that the HoloLens 2 itself even can't do. But, especially when you're working out on a loud construction site or an oil rig or whatever it might be, these type of remote assistant tools are very important, but you obviously need to be able to hear the person that's talking to you.
And Jordan, just before we move on there, one thing I noticed using the HoloLens, and you had mentioned to me that there's inward-facing cameras tracking your eyes. And what I found through personal experience, and maybe you can explain this technically, but it seemed like it enhanced the ability to interact as well with that technology.
Yeah, so I guess I mostly touched on XR10, but I didn't touch on some of the great functionality of the HoloLens 2 that Microsoft has added. So what Bryan is mentioning is kind of an improved sensor package on the new HoloLens, both outward and inward facing. So those inward facing cameras are looking at your eyes. And what that allows us to do is two main things. One is iris detection, so that you can do authentication through the device just by looking into it. But more importantly is it calibrates itself to every person that puts it on. So there's no need to go in there and adjust any type of setting. It will always give you the best experience based on the distance that your eyes are apart or where you're looking in the mixed reality environment. And then those new outbound or outward-facing sensors are doing some really cool stuff. For those of you who have used the first HoloLens, you may remember kind of this air tap motion that you had to do. It's kind of this weird interaction with your data that was a bit clunky. And so the new device tracks both of your hands out in front of the device. It's tracking 30 points of articulation on each hand. And what that allows you to do is literally reach out and grab holograms, pull them apart. If you have a menu in front of you, you literally click it as if it was a physical kind of billboard there in front of you. And so it's kind of pushing towards that idea that I talked about earlier of really mixing those two worlds together and making your mixed reality digital content interact as if it were physical content in your world. So I can tell you already from showing this to quite a few people, it's much, much easier to pick up this new device than it was the first one, simply because the gestures are instinctual. The idea of interacting with the digital data is much, much closer than ever before to actually interacting with physical data out on your site.
Yeah, and I brought that up for a reason, mostly because just using myself and showing it to customers, that they mentioned to me that, wow, this is now I can really see the value of how I can interact with this technology in the construction environment rather than before where it was like, yeah, I might be able to see how that could work, maybe in the office, but now they're telling me with this new technology included with the XR10 that, yeah, now I can see where the value is in using the product on site.
Yeah, it makes it a lot easier to give the information to the user without making it intrusive, right? Yeah. It's not always floating out in front of you. In our application, for example, you walk around on site and you might not be seeing anything at all, but as soon as you need to see something or you need to pull up a menu, you literally put your hand up in front of the device, and that tells the device, hey, I want to open a menu. And when you put your hand up, it opens the menu and all of your tools are there. It's like having a tool belt, a digital tool belt that is accessible at any time so that you can kind of jump between your digital and your physical environment.
Fabulous.
So I wanted to touch a bit on Sight Vision as well. I mentioned this is kind of our outdoor augmented reality system. It's made up of a couple key components. There's, of course, this bracket that you hold. It has a built-in EDM for taking measurements. It's all enabled by Trimble Catalyst, which is a software-based GPS GNSS antenna. It gives a few, depending on the subscription level, it gives a few centimeter precision, which is very, very good out on site. It's driven by the application called Sight Vision, which does have Trimble Connect from a cloud side driving it. And it's all ran off of a bring your own device type system. You just need an Android 9 smartphone. It's plug and play with the software and the GPS receiver. So you go out on site. It's, of course, excellent for visualization and precise positioning of this 3D data out on site, collaborating with other stakeholders on a project, and then bringing that data back in the office for reporting purposes. So we're starting to get up against a time wall, so I just want to tick through availability real quick for you guys. It's probably the information you're dying to know. I'm pleased to tell you guys that the XR10 is shipping literally within the next week. We do have a bit of a backlog on orders. People are very excited to get this device. But if you are interested in purchasing this device, it's $4,950 US, or the equivalent in other currencies. Our software, which is Trimble Connect for HoloLens that runs on the XR10, is available either in a monthly or an annual subscription. Monthly, it's $99 a month, and annual, it's $995 per year. And this includes all of the other features of the Trimble Connect platform, that are driven through the desktop and the web and the VR and the mobile applications. For sight vision, the hardware is $3,250. The software is again a subscription service. It's $250 per month or $2,000 per year, and this will drive all of those workflows outside in the field. This solution is also now delivering as of last month. A quick look, I said I wasn't going to look too far out into the future. I don't want to look 5 years out or 10 years out. I want to look 1 year out. There's three main reasons why you should be thinking about mixed reality right now, and they're all based on where it's going to be in the next year or two. The first is this idea of the mixed reality cloud. Today, a mixed reality experience out on a construction site is a very lonely experience. You walk out, you load your data, you visualize it, you turn your device off, and you go home. But in the very near future, all of this data is going to be connected up into the cloud. And it's going to be connected based on positioning and these devices building kind of this map at all times of your environment. And so what this allows us to do, as you can see here in a manufacturing example, but it works the same on construction, is this connectedness from worker to worker, worker to data, and worker to site. And so the idea is that Bryan could walk out on the construction site, he could see an issue, and he could tag it with essentially a virtual sticky note on that issue out on the wall. And if I came back a week later, I could be on my account, so a different login, I could be on a different device, it's obviously a different time, and I would see that same data. And so really what this is doing is creating these mixed reality devices being what we call edge devices. They're portals into this kind of subdimension of 3D data. And so in the future, we see this environment where the workers out on the site are wearing mixed reality devices. And in the same way that they collaborate through Trimble Connect or BIM 360 on the data, they'll be collaborating actually in situ in the context of the environment.
Sounds like a movie I saw about 15 years ago.
Yeah, exactly. So second on the list is the idea of remote rendering. This is coming very, very soon. Of course, one of the limitations of this is that our data is becoming huge. Like as we push towards constructible models and, the idea of BIM being more than just CAD and having all this underlying information below the CAD, our models are getting very, very large. And so what we're doing is we're offloading a lot of the processing to the cloud. And so in some of our early tests, this is like really showing some cool stuff, like millions and millions and millions of polygons being able to be visualized in HoloLens. And this technology really is there. The biggest kind of burden to this being out on a construction site today is bandwidth. You need to be connected in real time to the cloud. And so especially as we see the emergence of 5G technology over the next couple of years, the idea of not being able to open as much data as you want to out on a site just isn't going to be there anymore. You'll literally be able to see whatever it is you want to see at whatever fidelity you want to see it directly on the site. And then this leads us into that concept of what you see is what you build. We showed the examples from Consolis, kind of a controlled prefabrication environment, being able to walk you through building something. In my examples at the top, there's actually surgeons using HoloLens today for guided surgery. So they're taking MRI data and CAT scan data and they're overlaying it onto the patient as they're actually cutting into them so they can actually see spatially what they're working on. And so really the transition from this to a large scale construction site is just a matter of scale, and we're getting there very closely. And so basically, let's blow this up to full 1-to-1 on a construction site, hone in the precision, and we're very close to having that precision honed in quite closely, and being to a position where our workers, it's not just a pre-check or a post-check of the data, it's actually wearing a mixed reality device while they're doing their work and actually instructing them through a task and an install out on the site. So what to do next? As I mentioned, all of these solutions are available for ordering today and shipping either today or very soon. If you're interested in the XR10 HoloLens device, you can go to trimble.com/XR10 and request a demo or order it today. If you're interested in sight vision, please go to sightvision.trimble.com, and we'll have someone get in touch with you on that side as well. So with that, I know that we're a few minutes over, but if there are any hot pressing questions, Bryan and I would be happy to take them. Yeah, so great question. So one of the questions that came in was, does the price of the XR10 include the HoloLens 2 hardware? So yeah, it's a great question, and a distinction that I will make is that the XR10, it is a HoloLens 2 at its core. So when you pay that $4,950, you don't just get a hard hat and a couple adapters and then we tell you to go to Microsoft and buy a HoloLens. That $4,950 is a fully integrated device. It is, the XR10 is an accessory that has a HoloLens 2 built into it. It has that hinge, it has that bone conduction system, and you snap it down on your MSA V-Guard hard hat and you're ready to get to work. No need to go get a standard off-the-shelf HoloLens 2. You can think of it the same way as you can go to Dell and you can buy a Dell Inspiron laptop, which is your standard laptop, or you can go buy a Toughbook that's rugged and coated in rubber. They both have the same laptop guts, but one is made to actually go out and work on a site.
Perfect.
So another question that came in is, does the XR10 work with other programs like Revit? So really what that is a question of, is it compatible with my data? There's kind of two answers there. The first is that the XR10 is a Windows device. Of course, we're going to tell you to go use Trimble Connect for HoloLens, but there's a whole slew of other applications that run on HoloLens. And so it's a completely open HoloLens device. You can go, you could watch Netflix on the thing if you really wanted to. Within our applications, within Trimble Connect, I noted kind of that open environment, that we don't just take our own data. If you're using Revit or Bentley or other types of systems, Tekla, all of that data funnels into Trimble Connect for HoloLens, and thus can be run and visualized through the XR10. Another question, is there Trimble Connect integration with eBuilder? It's growing every single day. As you guys know, our eBuilder acquisition is still pretty new. It was just, last year, Bryan?
Yes, correct.
And so we are integrating Trimble Connect every day with eBuilder and through is it Project Site? No, not Project Site. What's the software package that's integrated with? But
Project Site is part of that. Yes.
Yeah. So slipped my mind. Sorry.
That's okay. But I think the overall connection here is Trimble Connect.
Exactly.
Everybody within the Trimble environment is sharing data through Trimble Connect. So whatever you're doing today, that data can be shared across platforms. Other direct integrations for specific workflows, as you said, is a constant thing that we're working on. So.
Yeah, and Trimble Connect is kind of meant to be, not only this unifier for different stakeholders out in construction, it's kind of an internal unifier at Trimble as well. For those of you, quite familiar with Trimble, we've done many acquisitions over the years, whether it's SketchUp or Tekla or eBuilder or Viewpoint, and the entire way through that construction continuum. And Trimble Connect is giving us kind of this central integration point to connect all these different systems together. I have the luxury with Trimble Connect for HoloLens being a client of that Trimble Connect platform, that as Trimble Connect expands their integrations to different tools, those tools inherently integrate out to HoloLens as well. So if Trimble Connect can open an RFI from eBuilder, then it will be very easy for me to then visualize that same RFI from eBuilder through Trimble Connect and out into the HoloLens.
Yeah, I think it's Trimble Connect is a fabulous platform neutral, agnostic ecosystem.
Yep.
I would say.
Yep. All right, so last question, then I'll let you guys off the hook. A question, of course, around accuracy in HoloLens, and in particular around prefabrication. So the accuracy question or precision, more so, is really driven by scale. It's much easier in smaller controlled environments for us to be more precise with our data versus larger scale environments like a construction site. So in the case of prefabrication, without any kind of external augmentation, so targets or QR codes, the HoloLens will overlay information to a couple centimeters, maybe 2-3 centimeters. if you add markers into the workflow, which I should put this out there that we don't actually have marker support yet in our application, but in our R&D thus far, when we add markers in that prefabrication environment, at times when the HoloLens is actively tracking a marker, which is pretty much at all times in a controlled environment like prefabrication, we can pull in sub-centimeter, maybe even less than half a centimeter. So very, very tight in those situations. Of course, as you get out on a larger scale construction site, the HoloLens is kind of in this larger environment where people have more freedom and room to roam, and it's further away from the kind of beacons and general structure that it uses to position itself off of. So when we go out and we do something like a clash detection, for example, and you align a model to a site, which is a pretty simple process, we usually see between 2 and 5 centimeters, depending on a couple of different factors. As you move away from that alignment, that anchor, it will drift over time, about 1% over distance. So kind of the best practice there is if you're doing a clash detection on the kind of northeast corridor of the building, you go there, you align your model, it takes 30 seconds, you do a visualization. And then if you want to go up to the 4th floor southwest corridor, the best thing to do is walk there and do another alignment, because by the time you get the whole way across that construction site, it's probably drifted enough that the information is not quite as precise as you want it to be.
Yeah, and we have other tools if you want to be super precise. So.
And as I mentioned earlier, especially with this idea of the mixed reality cloud and spatial anchors and kind of connecting this up to the world or up to the cloud, this is improving every day. And of course, the holy grail for us is being able to use mixed reality out on a construction site to guide people through the work that they're doing every day. And the one key component to that is, of course, precision. And if there's one thing, to kind of wrap this up in a present, if there's one thing that Trimble over our 40 years is very, very good at, it is adding precision to workflows. So you can trust that is where we're driving towards every day. So with that, we will wrap up. My friends here in the room are going to send this presentation and slide deck out very soon to everyone who registered for this webinar. The other questions we didn't get to, we'll hop in here and we'll add some notes, and you guys can have it for your own keeping. So thanks, Bryan, for joining me.
Thank you, Jordan. It was a pleasure.
Your expertise on the matter, and thank all of you on the phone, especially those that stayed 12 minutes over with us, for tuning in. Thanks, guys. Have a good day.